Hi everyone, and welcome to GDS's first live ever event. It'd be really nice if you could put in the chat if you're on your morning coffee or if you're on your evening glass of wine. We're all just hit midnight here, so I'm on the coffee. I think the boys are on the Red Bull. We were hoping that our sales director, Clayton, was going to do the introduction today. Unfortunately, he's not been feeling very well. We're still quite COVID cautious, so we've actually sent him off home. He's got a little pre-recorded message that we'd like to share with you first, and then we'll kick off with the event.
To reach as many of our customers around the world and make it a more palatable time for them. The event aims to highlight the capabilities and features of the EMDCSS machine to my left here. Features include the importance of frame stiffness, including top cap fixity and top cap rotation, very important when choosing a simple shear machine. Adaptive control, which reduces or negates the need for manual tuning, and automatically adjust the PID settings at every cycle so you get the maximum performance from the machine. Passive and active height control, which is a requirement of ASTM. CNS testing, constant normal stiffness, a very popular test now, specifically for offshore wind. Local strain, the addition of local strain transducers to measure directly on the specimen. Our unique shear load cell, which again measures directly on the specimen and removes any friction from the system from linear guides or ball screws. And the performance of the machine. For example, the machine can go to a frequency of 5 Hz with a double amplitude of 3.5 millimeters. We encourage questions throughout the event using the live chat function, and we'll get to as many of these questions at the end as we can, and if we can't answer them at the end, we'll reply by email. That's all from me. Hope you enjoy the event, and I'll hand you over now to Crystal Robson, our technical sales lead, who will take you through the rest of the night's events. Thanks very much for watching.
Hello, and thank you again for joining us for our first ever live event. If you have just joined us, please put in the chat where you're from, what you're drinking. So we're still on coffee and Red Bull here. So from our recent posts and articles, you'll have seen that we've recently shipped our 100th EMDCSS, which is why we wanted to mark the occasion. It's a brilliant achievement and something we're really proud of here at GDS. The system itself has been a kind of a unique experience for us, a real labour of love. And we took on customer feedback very early on in the design process, which is why we believe it's so successful. There's been an increase in demand for this system due to the wide range of applications of CSS testing, so Cyclic simple shear. Many engineering projects have soil that undergoes dynamic cyclic loading at some point in the design life cycle. So we're seeing CSS testing being used to simulate these sorts of events, such as earthquake engineering, mine tailings, and especially for the offshore wind industry. So cyclic testing for the offshore environment is there to simulate the wave loading, wind loading, the rotor frequency, and the blade passing frequency. When we originally launched the EMDCSS, it was originally for research customers. We've now seen that half of the systems sold have actually gone to commercial laboratories, surprisingly, and that's been in response to the boom in the offshore wind sector, which is continuing to grow, which is brilliant news for everyone. Quality is one of GDS's core values. So every one of our systems is manufactured here in the UK. It undergoes quality assurance testing by one of our system support engineers before it's then packed and shipped onto the end user. We pride ourselves on the quality of our products, but also of our engineers. So I'm very fortunate today to be joined by 3 members of our geotechnical systems engineering team, Michael, Waleed and Ted. They're going to be here to help me go through the features and benefits of the EMDCSS, to run a test, and then to answer your questions. So while we've got them here, please post your questions in the chat and we'll answer as many of them as we can at the end. We would also like to thank David and James. They're providing our technical support for this event and they've been brilliant. So just a brief overview, we're looking to do the system overview first. So looking at additional accessories and the various options you have for the EMDCSS. We'll then go to sample preparation, the GDSlab software, how to run a test. We'll then do a brief discussion around results and then go on to your questions. So I'd love to introduce to you the head of our system support, Mike Bully.
Hello all, it's nice to see a few familiar faces and some new faces as well. So we have our EMDCSS machine here, Electromechanical Dynamic Cyclic Simple Shear. We do a range of upgrades for this machine. Some are fitted actually in here, which we'll go through as we go through this section. It has capabilities of small strain amplitude around 0.005% and then up to large strain of 10% shear strain. It also does extremely accurate quasi-static testing.
So it's also available as a 5 Hz 10 kN configuration and can accommodate samples from 38mm to 100mm. And also we've now got it so it can take 150mm samples without altering the configuration. You can also upgrade to bend elements on any samples over 50mm and also do direct shear upgrades. The system is 420mm wide by 800mm deep and a metre tall.
I'll try and get this bit right, keep getting it wrong. It's 17 inches wide, 32 inches deep and 40 inches high.
And it weighs in at 220 kilos.
So that's around 485 pounds. These are considerations for obviously installation. If the machine arrives, it's got to be put up onto a bench potentially. So bench capacity, load capacities, all that sort of thing need to be taken into consideration. Orientation of the machine. Good orientation is frontward facing, so we get access from all 3 sides for sample installation, but it can be fitted obviously long ways on a bench and still give good access from 2 sides.
So the EMDCSS has a very high overall stiffness. This is particularly important when you're performing cyclic testing. You want to achieve accurate results, but not be measuring that machine compliance.
So we have the solid bars at the front, and then 2 very thick sections, front and at the bottom here. This is all surrounding the sample test area, so giving us a good solid foundation. We also use high-grade linear guides, and that reduces any vertical movement on the vertical carriage there during the shear stage. These are all considerations to take into effect when you're buying one of these machines.
So this is a dual-axis electromechanical system rather than a pneumatic or hydraulic system you may get from other suppliers.
So pneumatic systems inherently are restricted to sine waves. That's just because of the control problems with pneumatic systems. This machine will do sine wave, have a sine, triangle, square waves, custom waveforms, obviously up to 1,000 points as a custom waveform.
So our standard configuration has 2 vertical displacement measurements. If I just ask David to switch over to our other camera. No, perfect. So you can see our primary LVDT running down from here down to here. Your secondary is up at the top with the encoder, and then we also have the vertical upgrade add-on here.
So I'll just move the camera around, try not to make anyone feel a bit seasick. So inside here we have a primary horizontal shear LVDT, and then similar to the vertical axis, we use the encoder for a secondary. Fitted on the front here is our top cap LVDT upgrade. So this measures directly off of the top cap. So any slight movement in the top cap there is taken into effect, which reduces the compliance even further on the machine. So again, the vertical LVDT upgrade in here, again, more localized measurement, better for compliance. We have 3 load cells, an axial load cell just in here on the vertical carriage. Our unique, just a little bit further up, primary shear load cell design in here. So this sits above the sample, and then we don't see any of the friction build up in those lower horizontal linear guides. We also have a secondary shear load cell just at the back here. So this is a good reference load cell, but it's also used to protect the machine when those samples are installed. We use limit switches in the machine, both software and hardware. So we have an array of options for keeping the system safe. And then if we switch back, I'll just say, and also just a final abort button on the front here. For the load cells, we have a calibration jig. So this fits in both orientations. Full kit can either be done in 5 or 10 kilonewton configuration. So on the right hand side here, this is for axial load cell calibration. And then on the left hand side here, we can do both the primary and secondary shear load cell. We also do a calibration jig for the displacement transducers, and then again that can do all of the upgrade LVDTs as well.
So on this system, we've got two channel LVDT signal conditioning boxes. The standard configuration is 1 box. If you were just to add on the horizontal LVDT, then that box would then be expanded to 3 channels. This is our control box, our advanced DCSS box that's got 8 channels, logging channels, 24-bit acquisition, and uses a CAN bus connection.
We provide the system with a single phase isolating transformer such as this, and that comes in 240 to 240 or a step up in 120 volt to 240 volt. This is just to reduce the inrush current, and we can also run all the electrical devices through this to create a common ground. The LVDT box and the calamari box here, or the control box, they both come in dual voltage 120 to 240.
So, oh, sorry, onto you. I did that last time as well, sorry.
The machine can actually move automatically from consolidation to shear. So if we put it into active height control, we can transition that straight across, which is a nice handy feature for speeding up tests and moving things on if people aren't around in the lab overnight, things like that. The shearing stages we have available: monotonic shearing, dynamic cyclic simple shear, and then we can do static and dynamic CNS testing, as well as static and dynamic direct shear if the direct shear upgrade is fitted.
So one thing to mention about GDS software, you only pay for a software module once. It doesn't matter how many systems you have with us. We offer free updates, and most importantly, we have our own software development team in-house. So we'd like to run a little poll just to see why you're joining us today. So that should be flashing up on your screen now, just as we introduce Ted, who's going to be going through sample preparation.
Thank you very much. Just tie it up and transition across.
Hello guys, my name's Ted. Thanks for joining us tonight. In front of me, I have our 70mm size specimen preparation kit. You can get this in size range from 50 to 150mm, and you can customize it depending on your testing needs. Each one of the specimen kits will come with a base pedestal, 2 confining rings, which I've already screwed onto the pedestal. Underneath that is 2 O-rings, which I'll compress underneath that. You also get a top cap, as you can see there. And you also get some of these Teflon coated rings. So these rings are made of aluminium bronze. They're nickel coated and they have embedded PTFE. And PTFE is a type of fluoropolymer which is known for having low friction qualities. You can also pick up one of these vacuum formers separately. And as you can see, on the base pedestal, I have a sintered disc already screwed into the top. And it has a concentric pin formation, which is very useful when it comes to testing clays. But say if you test some sands, you may choose to opt for this type, which is our ridge formation. And recently, we've been experimenting with a new type, and that is with our plain disc. Just for the sake of today's demonstration, we've already previously produced a sample on that. But if you would like to see some of this kit in action and see me making up a sample, you can go to our YouTube channel or onto our LinkedIn page, where you can see it there. In a few moments, I'll have Dr. Waleed Khan come on. He's going to run you through a bit of the GDSlab software. He got his PhD from the University of Nottingham, where he specialised in transportation and geotechnics. Waleed's going to show you a bit about how the GDSlab software works, how it interacts with our EMDCSS machine, and also how you can see the data in real time. So you want to come up? Thanks again, guys.
Thanks, Ted. Hello, everybody. Today I'm going to run a latent measured sand sample using EMDCSS machine, and I will also demonstrate our GDSlab software, how to perform these tests. Click on the advanced DCS box here for some more options here. So this window here in the channels, they are the same transducers which are shown here, but it's quite easy to apply offsets here and to the calibration values. Then we have some other tabs here as well. The waveform one, you can select different type of waveforms as well as custom waveform as well. The docking option here, it's quite a useful feature if you put your sample and if you want to move the actuator down until there is a load value detected. Here it's 0.03 kilonewton, and it also shows you how much travel you have on the system in terms of upper and lower limits. So I'm not going to demonstrate the other tabs here. If you are interested, you can refer to the GDSlab handbook. So I'm going to jump, before starting the test, I'm going to apply offsets on all the transducers here. and exit, and now we are in the test window. So I have already entered the sample details here for the 70mm sample. So the first thing I'm going to do is, there are different options here in terms of test modules. I'm going to go to the advanced shear and apply 25 kPa axial stress on the sample for the preconditioning. So for reconstituted samples such as sand samples, preconditioning is required to have a proper contact between the sand sample and the top cap, and also to eliminate some undesired stresses, non-uniform stresses in the sample. So there are a few options here in terms of stresses and strain, which are, you can see here in the screen. So in terms of stress, I'm going to apply 25 kPa on the sample and keep the horizontal stress strain constant so that it doesn't move. And so I will, there are some other options here which are explained in detail in GDSlab, in the GDSlab handbook. So that's the test window, and I'm going to start my test. Well, it's going to apply that 25 kPa on the sample. I'm going to go to the dynamic shear stage, and I'm going to apply preconditioning on my sample. So in the frequency, I'm going to put 1 Hertz. In terms of, so it's going to be a drain cyclic simple shear test. Load control, so I would keep the current value constant, which is 25 kPa. For the stiffness, I'm going to enter one value because it's the system is adaptive control. So it's going to adjust its control gains when the stiffness of the sample changes. For the preconditioning, it depends on the material type. So I'm going to apply 0.01 millimeter here of amplitude on my sample while it's under drain condition, and I'm going to run 100 cycles. And in terms of other values, so it's going to be on displacement control. So those are the real-time windows which are appearing here for the test which is running. As you can see, the horizontal LVT is controlling very well in terms of the 0.01 millimeter displacement. While we are waiting for these preconditioning stage to finish, in the meantime, I will define another test stage here for the consolidation. So for the consolidation, I'm going to apply 100 kPa on my sample. For the advanced shear module, which I'm showing right now, it's for the static loading conditions. And there are different options here. So in terms of, if you want to control on the displacement, in terms of stresses or constant stiffness value, you can run constant stiffness test in terms of the monotonic shear test. So I'm going to use axial stress option and target 100 kPa on my sample. In terms of the horizontal stress, I'm going to keep the same displacement value constant. As I mentioned, I'm not going too much in detail into all these options, but they are explained in much detail in our GDSlab handbook. So now a few seconds left to complete my test, and then I will jump to the next stage to consolidate the sample. So that's 100 cycles completed. So now I'm going to the next stage to consolidate my sample. So 100 kPa stress applied. Normally for the consolidation, you're going to wait for a longer period of time. It's a dry sample, so we're going to leave it for just a few minutes to finish the consolidation. While I will go to the dynamic shear stage and define my test conditions for the constant volume cyclic simple shear test and explain a few tabs here. So for the constant volume cyclic simple shear test, I'm going to use a frequency of 0.1 Hertz. And in terms of axial control, it will be a displacement control. So I will keep the current axial displacement value so that the test is run as a constant volume test. And for the shear one, I'm going to put a cyclic load, which is going to be a CSR value of 0.15. I'm going to put a value of 1 here. And apart from that, if you want to run dynamic constant stiffness test as well, the option is here from the dynamic stage as well. So you can run constant stiffness test under static condition as well as under dynamic conditions. Yeah, so we are running a poll now to ask for the number of cycles we have to run for the constant volume cyclic simple shear test. And once we have the result, I will enter the number of cycles here. Right, so let's run the test now. I have entered 100 cycles for the test to complete. Yeah, let's see how our data looks like. So I have started my constant volume cyclic simple shear test. So the sample already filling. You see, it just took a couple of cycles for the sample to fill. Probably a high CSR value for the sample to take. But we have run some tests on our EMDCSS for constant volume cyclic simple shear test, which I'm going to show here. So this was the test run at 0.1 CSR and consolidation stress of 200 kPa using our EMDCSS machine. As you can see that with each number of cycles, there is a drop in the normal stress until it reaches around 70, 75, and then from 50 onwards, there is a sudden drop in the load and the sample fails. So because it's for this constant volume cyclic simple shear test, the drop in normal stress is taken as equivalent to the excess pore water pressure generation, which will occur in a truly undrained test. So you can see that the excess pore water pressure is going to increase, and after 26 cycle, it suddenly reaches 200 kPa and the sample fails. For the shear strand, it's showing nice hysteresis in the beginning, and then in the around 25, 26 cycles, there is a big drop in the shear strand and the sample phase. And this is also results from some of the constant normal stiffness tests which we have run on our EMD-CSS machine, which compares data, 3 different types of data. One is very high CNS value with a small shear displacement. Another one is a small CNS value, which is 625 kPa with a small strain displacement. And the third one is a small CNS value and high horizontal displacement value. So it shows different, all the data which are compared here, and our system is capable of doing these constant normal stiffness tests. So now I would ask Mike and Crystal to come here and continue from here. Thank you very much.
Okay, so we've had only a couple of questions come in. First one, I think Clayton's already answered nicely for us in the chat. Yes, this has been recorded. For those that have registered, we will be sending out either a copy of that, or obviously we have all the attendees' information. So we'll send out information on how to get hold of that, and obviously, yeah, some of you would like to distribute that around some of your colleagues that were unable to make it. So yeah, we'll be able to do that as well.
We seem to have raced through that quite quickly. It might be all the caffeine that we've taken to make sure that we're going to stay awake. So while you guys are maybe thinking of some more questions, while we've got the undivided attention of Mike, Waleed and Ted, we'll run a poll just to kind of find out if it's worth us doing some more of these live events. You can say no.
If you put the poll up there, Dave, I'll just have a quick look at some of the other questions coming in.
So for myself, it's been really nice seeing some of my customers from my territory pop up on screen. So I cover Asia, Australia, New Zealand. So it was nice to see questions from Shahui. So hello, down in Melbourne. Was lucky enough to be out there last month for the conference. And we seem to have quite a few others. We've got Indonesia, we've got Korea. Who else have we got on there today? I know we've got some from George's territory, so over in Brazil, Peru. Have you got anyone from Europe? Has anybody tried to stay up late tonight? Or is everyone trying to catch the recording?
Okay, I'm back on the screen, yep. Sorry. For the first one that came through, I think for irregular period and about custom waveforms. So the custom waveform, we can load in 1,000 points in a custom waveform. So irregular waveforms, yes, you can load in an earthquake waveform, for example, with multiple peaks. Obviously, in terms of the amplitude and the frequency you set in the machine will be determined by how rapidly you want that to change within that period of time. So yes, it can be done, but there are some limitations around making sure you get the right amplitudes and frequencies set in there to run that irregular waveform within that 1,000 points. I think Waleed's got a quick question he's going to answer, and I'll double check on the next one.
I think one of the questions we got before the live event was if you could incorporate vendor elements. So I hope we covered that off for you fairly near the beginning. So yeah, vendor element upgrade can be done on any sample size over 50 millimeters in diameter. I think there's some other questions. We got a lot asking if we've got the time wrong because everyone was looking midnight in the UK. There's no way they're staying up that late, but we are. This is live, as you can probably tell from the few little pauses we've had. The boys are still conferring. Have you got any other questions coming through?
Yeah, I think if you put the graph back, I think the question was about the start of the day.
Right, so someone asked that there is a was the question?
Non-zero shear stress. And
Yeah, non-zero shear stress in the beginning. So that's because of the shear bias. If you consolidate the sample, so that's in the sample when the shearing stage was started. So
yeah, it's because it's got a fixed.
yeah.
During consolidation, it's fixed displacement. So yeah. Okay, let me just answer the other one. So the steel block vertical shear. We're currently running tests at the moment. Actually, as I think Clay wanted a quick discussion on this as well potentially. So we're looking at the compliance in the machine and how we can further improve that. So we're looking at a potential for adding in a virtual transducer. This is where we'll actually run a test on a steel block, and we can actually load that into the software and have an output that's already in corrected displacement. So what I'll do is I'll grab your email address off the attendee list, and I can send over some data actually that we've got from loading on a steel block.
Right, so we have a question about EMD CSS and confined EMD CSS. What's the difference? So in the conventional EMD CSS test, you don't measure the pore water pressure. You kind of deduce it from your test data. That drop in the normal stress is equal to the excess pore water pressure generated. In the confined one, you are actually measuring the pore water pressure in the sample, and you can saturate the sample.
So the confined EMD CSS was one of the newer systems that we launched at the end of last year. So we've only sold about half a dozen of them at the moment. So maybe in a few years' time, we'll be doing a presentation because we've shipped the 100th EMDCS Con. You never know. Is there anything else? So it's nice to see the results of the poll that you think we should be doing more live events. I thought there was going to be a heavy-handed no, stick to doing YouTube pre-record. So it's nice to see the interactions paid off. It might also be worth you guys dropping us an email and letting us know what the systems are or what the features are that you'd like to see more content on. I know that we're quite keen. Waleed's actually, Dr. Khan is working on a paper on the constant normal stiffness at the moment, which we're hoping to share in the coming weeks. But yeah, just let us know what you want to see. We're lucky to have a nice dynamic team at the moment who are more than happy to do content and stay up till midnight.
Not so happy.
Okay, Ted's not happy. But we have fed him a lot of Haribo and Red Bull, so yeah. Anything else, Mike?
Just quickly on the question about the internal pressure controller. Is that to do with the EMD-CSS confined? If you can just drop that back in the comment there, we'll answer that one. And then for unsaturated samples, that's a very big topic of conversation. To saturate all the way at the start, yes, you can go all the way to 100% saturation and then work backwards, depending on whether you're doing a soil water characteristic curve to look for your values that you need. If you've got those values, you don't necessarily have to start from 100% saturation. So we obviously use the high air entry discs, the ceramic discs. For the EMD-CSS confined, you can do that unsaturated testing. So you'll have the outside pressure, and then we'll add in the air pressure in the top of the sample, and then pore water pressure from the bottom. So yes, we can then measure the matrix suction and change those values. But yeah, you can do it either way around. If you'd like more information on that, it's easier to probably have a separate conversation out of here because it can be quite a long topic.
So this isn't your only opportunity to ask GDS questions. If you think of anything else, or if anyone's watching the recording, please send in anything you'd like to ask us to info@gdsinstruments.com, and we'll get back to you as soon as we're able. But like I said, it'd be really nice to know what else you want to see from us content-wise. We're in this nice position at the moment where we've got a team of young engineers that are keen to do content. So take advantage, help me, help me to help you guys. Anything else to add, guys?
No, any other questions we'll go through as well. We'll just, yeah, like I said, we'll just run through emails and get everyone an answer. So
Perfect. All right. Well, thank you again to Dr. Khan, Ted, Mike, and David and James. And yeah, hope to see you guys all either in person or on screen for video calls in the very near future. Okay.